Okay, in this video we are going to see how to prepare data in HEC-GeoRAS for a HEC-GeoRAS application. So in order to do that, the HEC-GeoRAS is not the standalone program. So we need to have the GIS and the format of the HEC-GeoRAS we use should be compatible to the GIS version. In this case, we have GIS 10 and the HEC-GeoRAS is the one compatible with this version. So now we are going to add the digital elevation model data. Okay, so because in order to work or in order to convert the data that the RAS or the GeoRAS needs, like the team data, we need to either have the elevation data in a form of contour or in a form of dam. So in this case we have a dam, and we can create the thin or triangular regular network from this one. So this is a big area, so we need to minimize this and zoom down to some specific region to deal with. So let's deal with this smaller part, or this smaller river. Okay, so to do that you need to clip your file. So you can clip your file in with a shape file. You can clip your file with the polygon shapes, or you can clip them with the triangle. So now we're going to do it with a rectangle. Okay, so this is a spatial analysis, and under the spatial analysis tool we have extraction, and then use the extract by rectangle. Okay, so this is your input raster, and then this is the region we need. Okay, so from this river the maximum and the minimum x and y value should be found. So if I consider this the minimum x value, so it is 38.595, and the maximum one will be from this direction, so it should be this point. So it is 38.773, 38.773, and let's consider the minimum y as it is this one, which is 5.99, basically 6, and let's consider the top or the maximum y, this one, which is 6.23. You can view the data from the bottom of your GIS toolbar. So this is 6.323. 6.323. Then you can save this file anywhere you like, and you can extract them or with the rectangle. So this is the extracted region, and we can avoid this one. We can only deal with the smaller one. Okay, so this is our region of interest, and the elevation range is between 1780 to 2025. So this is the river system we are looking forward to work on. So we should be able to convert this into thin, which is this is dam. Dam is a raster data, which means the rectangular pixels represented by one elevation, and we have to convert to a triangular one, so a regular triangular networks. So for that you can go to Arc Toolbox, and then you will find 3D analysis tool in conversion, and under conversion you have from raster. Okay, then from raster to thin. By using this function we can convert this into thin. So input your raster data, and this is you can save anywhere you like, and minimize this value as much as possible to 0.05 for example, and maximize this number of pointers to be created. That will increase the accuracy. So say okay, and the GIS is working, and once it finalized that, we'll be having the triangular regular networked file, and that will help us to create shape files that we need to export to HEC-GeoRAS. So here it is. So we have our triangular network format. That is all the data we need now, and then we can avoid this one. So this is the region where we're going to model in HEC-GeoRAS. So if you want that, you have to first find the river streamlines and the banks of your river and all those sorts of things. So let's deal with this one. So in order to create the RAS geometry, we have HEC-GeoRAS here. So this is a HEC-GeoRAS geometry. Then create a layer. So the most important features we need to create here is, one is the streamline, the second one is the flow passes, the banks, and the fourth one is the cut lines, or the cross-sectional cut lines. So we need to extract those shape files, and before that we have to create them and then digitize it. So here is the create RAS, then create streamlines. This will create the stream flow line. So before you proceed with this one, you need to save your file. Okay. So save the bus, that's 2. Okay, let's replace it, and then now we need to create the RAS geometries. So this is the RAS geometry. Then create a streamline and say okay, this is the river. It is created. This will only be finalized after you digitize it, so that is what it says here. And then you can create again the bank lines. Okay, you can say okay, and you can also create the flow passes here. And again you can create the cross-section cut lines here. Create the cross-section cut lines. So these are the 4 important parameters we need, and we can create them easily. Okay, so So in order to start editing or in order to start digitizing, you'll say start editing, and from this you can select river. We start with the river and say okay. Then here are the parameters to be digitized. Select your river, select this one as the point editor, the linear editor. So you start digitizing the lower elevations, which is colored by watercolor. So let's digitize it up to this point. That is good enough, for example. So when you finish it, double click and okay, then this is your river line, central river line. And then now you have to go to stop editing, and then it asks you to save this edited file. Say yes, and so then the river has been digitized. Okay. And then the next is go to start editor again. Then now you have to edit the banks and say okay. Okay, and then select the bank, and this will be active. And then you have to digitize the banks from the left side, for example this way. And double click when you finish it. So this is the bank line, and then one left bank line, so you have to do the same thing on the right side. Okay. You can double click it when you finish. Then this is a bank line, so you see the red lines, so they represent the bank lines. And if you want to save them, say stop editing, and then yes, and the file will be saved at the left bank and at the right bank. So you have created the left bank, you have created the right bank, you have created the river system. Now we need to create the flow paths, whole flow paths. So for that, again, go to start editing, and then flow paths, then okay, then you have to select the flow paths here, and then start digitizing on the left and the right bank. So consider this to be your flow paths. Okay, so this is the left flow path, and then do the same thing for the right bank. The flow paths are the maximum range through which the water can flow. So you can finalize it by double clicking. So now you have created all the trees, and now we left with the last one. For this one, say stop editing, and then say yes, and now you can start editing for the cut lines or cross-sectional cut lines. For that, say start editing the cross-sectional cut lines, and say okay. Then you have to select the cross-sectional cut lines, and then you can select the cross sections and double click it, and then select the cross section, double click it, select the cross section, double click it, select the cross section, double click it. So do that throughout the reach. So now we have finalized the cross-sectional cut lines, and you can stop editor and save the file. Okay. Now the file has been saved. You can avoid this one, and also you can see now the digitized map. So the central line indicates the river. So you can this indicates your flow path. You can change this flow path to black, for example, and increase the thickness. This is the flow path, and this is the bank. You can increase the thickness too. And this is the river streamline. The center one indicates the river streamline. The others are the cross-section cut lines that you have obtained. So now one main advantage is you can export this RAS data. So say export RAS data, and then this is where it is going to be saved, practice section A. So I can change that folder. So if I can change it to D, C, if I can save it in here, so practice, bring that, say OK. Then it will export all the data that we have created, and RAS data has been successfully created, and you can say OK. Then this is how we create a file in HEC-GeoRAS and export it to HEC-RAS. So this file is a GIS file. You can open it in you can open it in your HEC-RAS, and then do the rest of the analysis as per it is needed. So this is all about how to export data from HEC-GeoRAS to HEC-RAS.